Determine the slope of the graph. Now when we say the slope of the graph, that's a little bit of a, we have the slope of a line. If we do the slope of a graph, what we're saying is the slope of the line that's tangent to the graph, okay, that's what we're really going for. The slope of the line tangent to the graph. Okay, determine the slope of the graph of this function at the point 2,5 using the limit definition. So we've got the slope of the tangent equals the limit as delta x approaches 0. And again, I can't emphasize enough, write this down every time, every single problem. Just write it down. If you write it down, you're going to have it memorized when you need it. Okay, so the slope of the tangent is the limit as delta x approaches 0. Now, there's a couple of ways we can go about this. This is giving us a specific point to work with. We have ways of getting the general idea, and I'm going to try and give you both of these. It won't be today, of course. But if we're looking at the point 2 and 5, f of 2 is going to be 5, and we know that. So this would be f of 2 plus delta x minus f of 2 divided by delta x. Now here's where all the work with limit or with functions comes into play. The limit, delta x approaches 0. How do you put 2 plus delta x into this function? And the answer is very carefully. 9 minus 2 plus delta x quantity squared minus 9 minus 2 squared. I'm just replacing the function with its input expression. In this case, is 2 plus delta x. Limit delta x approaches 0. This is going to be 9 minus, and I'm going to put this inside parentheses, 4 plus 4 delta x plus delta x squared minus 9 plus 4 divided by delta x. Why can't I use direct substitution? Makes the denominator 0, right. Okay? Makes the denominator 0. I can't use direct substitution. So I'm going to have to find some way to get that factor of delta x canceled. And the only way I can do it is if there's something up here that I can factor delta x out of as a factor of the entire numerator. And if we look at this numerator here, let's see, this would be 9 minus 4 minus 4x minus delta x quantity squared. Be careful of your negatives. That is what is going to trip up some people, and it's so unfortunate that happens. But at this point, every term, whoops, let's do it this way. At this point, every term that does not have a delta x in it is going to cancel out. Every term without a delta x. Why is that important? Yeah, I've got to be able to factor out a delta x from that numerator. If I still have a term up here without a delta x in it, I've made a mistake. I've made a mistake. So if I factor out a delta x, I have, let's see, this should be a delta x here. So I would have negative 4 minus delta x times the delta x, divide by delta x. I'm trying to hurry. Delta x. And those will cancel. Now can I use direct substitution? And the answer is yes. And my answer would be negative 4. What do you think if you put this graph, this function in the Inspire, you would end up with a parabola, what we call a concave down parabola. If I have this, let's see, here's 2, and let's say this is 5. If I have this point and I have this parabola, let's see, it's going to have to probably be doing something like this. There's that point. If I had a tangent at that point, what would the slope of that tangent look like? It better be -4, okay? The slope of that tangent had better be -4. How could I prove it? Graph it. Yes, I can graph it. Practice doing that, please. Okay, we are going to pick this back up then on Thursday. I need to have your handout, those worksheets. Make sure that